start pi over 2 to the right. Now it can feel overwhelming where to start. Start with your middle, start with your max and min, and then we're basically getting our first point, pi over 2, 1 to the right. So pi over 2, 1 big tick mark to the right. We end after 4 pi, so I still have to say the shift is 1 to the right on the midline. Halfway should be 2 pi, but again 1 to the right on the max. Right there. Halfway in between here, we could just again start counting tick marks at your max, at your minimum, and here's your complete wave. And this is now dealing with radians. This is called a standard of excellence level question because we did have to factor out that b value to see the proper shift. But again, I like to count sometimes with 8 or 12 tick marks to get a nice, easy division instead of dealing with 1, 2, 3, 4, 5 tick marks, which doesn't divide as evenly. There's occasionally a bit of a weird scenario where we're dealing with numbers that seem a bit strange, like 2 to the right. And it might initially seem strange until you actually see the scale. So I can look at this and say the middle of this graph is 1. Amplitude is 2, so up a couple, down a couple. Get our overall structure. Middle of our graph, max, min, and for our max, min, amplitude period is 2 pi divided by 0.25 pi. That number actually cancels out a lot. 2 divided by a quarter is actually 8. It's going to take 8 radians to make a full wave. This seems strange because there's no pi in it, but it's actually unbelievably convenient because it takes 8 to make a wave, shifting 2 to the right. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say this is 8. There's no pi's in this. That 1, 2, 3, 4, 2, 1. Really, this is going to be a much more convenient scenario than we're even used to. So let's start our cosine graph. Please don't ever forget to double check whether it's sine or cos. Cos graph starts 2 to the right. 2 to the right is where we start on the max. We end after 8, which is 2 to the right on the max. Halfway in between the 2 and the 8 is supposed to be at a 4, but again 2 to the right on the minimum. Halfway in between a 2 and a 6 is our 4 on the middle. On the middle. So here's your V-like shape for the cos graph, which kind of makes that C-like shape. What's interesting about this is that if I were to ask, we'll go back a little bit further to the left. It took 2 tick marks, or 2, to get from the max to the middle. It should take another 2 to get from the max back to the middle. So we could actually say maybe a cosine graph was actually a poorly way that this question was created. Maybe we could have said instead to sine, a sine graph with no shift. Sine of 0.25 pi x plus 1. This graph would have made the same thing. But what's actually convenient and sort of strange about this is that the scale is not involving pi's, it's involving numbers. And these numbers are still radians, just like the example above. So there's one last question that I'll task us with just before there is some time for practice. But this question gives us limited information. It says the first maximum occurs at 2, 8. The first minimum occurs at 6, 2. These coordinate locations are just like we've seen before, but this time with a trig function. Determine the period, amplitude, and midline. So the first maximum occurs at 1, 2, 8. There's your maximum. Ceiling. The first minimum occurs at 3, 4, 5, 6, 2. Minimum. Floor. So make it look something like this. Now, question is, what is the period? Well, the time from a max to a min is from 2 to 6. That's 4. It's going to take another 4 to get back from the minimum back to the max. So 4 and 4 is going to take your period to be an 8. 2 to 6, max to min. Another 4, min to max. So period is 8. From there, we could get our b value. What's the amplitude? Well, we have a max. We have a min. So amplitude is max minus min divided by 2. 8 minus 2 is a 6 divided by 2. The amplitude is 3. Where's your midline? Well, this is again a max and a min. This time adding them together, dividing by 2 to get your average, which is 5. So occasionally we're given these conceptual questions with limited information, but asking a little bit more in depth. I'll save a question like this for practice, but we are essentially applying the skills that we learned today. Good luck.